Hello everyone, this is Akshay and welcome to our GFG beauty streak of day 98. So, let's see what the question today is about. And if you're new to this channel, please like, share, and subscribe so that we can grow and maintain our streak together. So, let's now jump to the question. It's already late, it's like 3 a.m. in the morning. So, total decoding messages. It's a medium category question with a massive number of submissions. So what it says is a top secret message containing letters A to Z is being encoded to the numbers using the following mapping. That is, A maps to 1, B maps to 2, and Z similarly maps to 26. So you are an FBI agent, okay? I'm an FBI agent. So you have to determine the total number of ways that message can be decoded. As the answer can be very large, so return the answer modulo 10 power 9 plus 7. Okay. There is a note there that an empty digit sequence is considered to have one decoding. An empty digit sequence, that is, we may have 0. If it's 0, then you have to return 1, right? So it may be assumed that the input contains valid digits from 0 to 9. If there are leading zeros, extra trailing zeros, or two or more consecutive zeros, then it's an invalid string. Okay, so if there are zeros in the starting of the string, then you just have to return 0. If there are zeros in between also, then have to return 0, right? In those cases, the answer will not cease to exist. Okay, so let us verify these node things as well, that they are saying the leading zeros, then extra trailing zeros and consecutive zeros. So I checked for consecutive zeros, and if I hit and compile and run, it says the expected output is 0, right? Similarly, you can check for the test cases like 0, 1, 2, 3. There will be a leading zeros of 1, 0. So it will be 0 again. And similarly, you can check for 1, 2, 3, and then 0. Just the four digits, and then also you will get 0. Okay, so I verified that part. So if the input is 1, 2, 3, the output is given as 3, and the explanation is 1, 2, 3 can be decoded as ABC 1, 2, 3, and then 12 become a pair and 3 is alone. So LC, and 1 is acting alone and 23 as a pair, that is W. So one thing, as you can see, that the pair you are making 26, if it goes beyond 26, right? If it's not in the range of 1 to 26, then also we cannot consider that pair as in our answer, right? Similarly, for 90, as you can see, there are leading zeros, so it says that it's an invalid string and we cannot decode. Okay, so constraint is 10 power 4. Okay, so how we can solve this question is, let's say we have a string of 1, 2, and 1. So what are all the possibilities I can make from here? I can make as 1, then acting alone, 1, 2, and 1. Every digit is acting alone. Then 1 and 2 will act as 1, and 1 will be alone, right? And then the first one will be acting alone, and the last two will be acting as pair, right? This is very obvious. But I have to solve this question. If the string changes, right? We need to traverse in such a way that we get the possibilities of this string. So suppose if I add 3 here, right? So what can I say is that uh, our new our new answer will be dependent on the count of the answers we find in the n minus 1 string. Like if I solve it manually now, so if I can just write 3 here as an individual strings, as an individual character, and I can say now, instead of answer of 1 to 1, now since I added 3, the complete answer will be 1 2 1 3, and then 12 is acting and pair, and then 21 acting in pair, and all these trees are long. Also from this thing I can say, so this was the thing, when this was the answer, when the extra string, that is 3, is not acting as a pair, right? Is not taken as pair, right? It was taken as an individual character. But what if you can take this thing as pair? Then from this thing I can see that 1 2 and 1 and 3 can be acting as pair, right? And from this, the second possibility, I can say that 1 2 will be acting as pair, and 1 and 3 we can combine these two, right? Similarly similarly I can say that 1 21 and 3. Okay, I cannot combine it here because the just behind character of the 3, that is 1, it is already is pair in one another character, right? So I cannot do this. So now I can say that my answer was previously, if I just use 1 to 1, the answer was 3. But when I added one more characters, 1 2 1 3, my answer becomes 5. And if I closely observe, then what are all the things that was actually happening? There were only two cases, that when I add a new character, it was saying that I can be added while not taking as a pair, and I can be added while 3 is taken as pair, right? And how is this solving? How the numbers are getting into our answer? We can say that while the 3 was not taken as a pair, it depends on the n minus 1 answer. Like the answer, the possibility you are getting from 1 to 1, right? And when you say that the 3 is taken as pair, then you can say the answer was 2. And actually this answer was nothing but when you have considered the n minus 2 possibility, that is n minus 2, that is 1 2. If you tried considering the possibility of these two, you will get answer as 1, and then it is 1 2, right? It is individually or you can pair it, right? So there is 2. So I can say, so here carefully, this is our entire logic of our code, that when I add a new character, there are two possibilities, that to add that character in not taking as a pair and add that character in taking as a pair. And we observe that the answer, that the number of possibilities we are getting while taking as a pair was nothing but the possibility of answer we are getting from this n minus 1 string. And while taking as a pair, then the answer was nothing but the possibility of all the answers we were getting from the n minus 2 string. Because this was the thing, because we were attaching what in the taken as pair, we were making this pair. So all the answers in the previous of this can be attached with this pair to form a new answer. I hope I'm making sense and you're getting the logic. Similarly, for this last three, I'm not taking it as pair, so all the possibilities coming from this string can be attached with just one 3 at the end, and new answer will be becoming as 3 as our last character. I hope you're getting I hope you're getting the logic. That's all we just need to code, right? And as you can see, while I explain these things, I was always talking about n minus 1 and minus 2, right? I So you can clearly visualize that there is recursion happening, right? So we are just leaving the things on it, that it will be be evaluated in the future, right? So let's code it. So what are some base cases that the starting character should not be 0, right? In that case I need to return 0. So let's first of all uh, what handle that case. So if it is 0, then I will say that return 0, right? And then I will just pass a function, let's say return solve, where I will pass the string str comma int, or no, not string, just the str, right? I passed it. And what is int? That int n is str dot length, right? So let's make a solve function and we will see that how we can write it actually. So int solve string str comma int n, right? Right. So what will be the base case? What will be the base case? So we will derive the base case from our dry run itself. So let's jump back to the paint section. So what I was doing, that I was traversing from this thing, and I was taking the two possibilities of taking as pair and not taking as pair, and I was then iterating for n minus 1. I was iterating for n minus 1, and I was so like opening a branch for n minus 1, opening a branch for n minus 2. So what is decreasing? So how we write the base case is that whatever you are calling, I am calling n, right? Then I'm calling n minus 1, then I'm calling n minus 2. That is one set, that is for the smallest character. For n equals to 2, I will hit the base case of n minus 1, that is 1, and I will hit the base case of n minus 2, that is 0. Base case is nothing but the smallest value where it is acting, where you are stopping your recursion. What is happening there? That is your base case, right? Okay, so for n equals to 1 and n equals to 0, what can I say? That this is nothing but I am going out of characters now. I don't have characters beyond 0. Like uh, 0 is our just starting character. Like, so I am out of characters. So if I just write I am out of characters, this is represented by 0. And for n equals to 1, what is n equals to 1 representing? That you have in str just one character. Just for one character, you can say there is only one way, right? There's only one way. So that means in both of these cases, I need to return 1, right? Right? And also for n equals to 0, right? So for n equals to 0 and for n equals to 1, in both of the cases, we need to return 1, and I explained you. And you can see that the empty digit sequence is considered to have one decoding. So you can take the help of this here also, which is saying for n equals to 0, you have to return 1. And obviously for n equals to 1, there is no other possibility of just returning 1, right? Okay, so let's code the base case. So for n equals to 0, or n equals to 1, we need to return 1, right? So I'm not writing the comments what n equals to 0 or 1 represents. I already explained it to you. Or if I just write it for you, it will be like more helpful to you. So for n equals to 0, that it means that I'm going out of characters. And n equals to 1, this implies obviously the answer will be 1. Suppose there's a string with one character a, then if you try all the permutation, it will be just 1, right? Okay, in the meantime, in the meanwhile, where's my mouse? Yeah. In the meanwhile, if you encounter that if at this thing that if str dot char at equals to 0, is 0 as equals to 0, then we have to return 0. So you can argue me that bhaiya, you already have returned here that str dot char at I is equals to 0 and return 0. So I'm talking for the cases where the initial digit was 0, but I started from like 1 1 2 3, right? This was the case I'm discussing for. Hmm, or I can just say, that this case is not required. Yeah, this is not required. So I need to make a variable count. So if count equals to 0, right? And what I need to do, I'm traversing from n minus 1, right? And I am opening for two branches. I'm on at n, and I'm opening two branches, n minus 1, and that is n minus 2, right? So I will just say that if str dot char at I cat n minus 1, it should be greater than equals to 0, then only I can iterate, then only I can process it, right? So if that's the case, so let me take you to the dry run again. If that's the case, that this is n minus 1 here, that this, the last character is actually n minus 1, right? So this is n minus 1 here, and I can see that this is greater than equals to 0. And if that's the case, then I need to get the count of this n minus 1. So I will just pass the n minus 1 in my function, right? So I will just pass it. So I will say I need the count, and I will store that in my count, and I will say solve for str comma n minus 1, right? That was my first branch, and this implies that I am not taking as pair, right? I hope you're getting this point. Now the second thing was that I was considering the characters as pair, right? So what I need to pass, so first of all, this was the first character, and I then operated on it because that was greater than 0. But now you're talking about a pair, so this is something. So and the range where the it is valid is, let's say x is 1 less than equals to 26. So I can say that the first character will either be 1 or either be 2. So what about this thing? It will surely be less than equals to 6, or I can say that less than equals to 7, less than equals to 7. And if this is the case, then we can take those things as pair, right? So if I write a pseudocode for you, then I will just say that this is my, let's say, n minus 1 pointer, and this is n minus 2 pointer. So I will say that if str.char at n minus 2, right? Let me write it for you. Let me write it for you. So I will just say that if str dot char at n minus 1, or let's say n minus 2, is equals to either 1, or str dot char at n minus 1, or it is equals to 2, right? This is for n minus 2, and the last character, the character which I'm at, should be less than 7 or less than equals to 6. Then only it will it will in the form of the valid string, right? So n minus 2 is less than, I will write 7. That is it. If that's the case, then what I need to do that I have to consider this answer, the previous answer. Okay. So the in that case, what I need to do that I have to consider the previous answer, that was 3, and the answer from n minus 2, that was 2. Then only I was saying that 3 was becoming 5, right? It was nothing but 3 from here, 3 from this box, and 2 from this box. 3 plus 2 equals to 5. So let's code that thing also. So I will say that count is nothing but plus equals to, or let me write it fully. Count plus solve of str comma n minus 2, right? And since it has taken to take us the mod, so let's write the associativity rule also. The percent mod, right? So that is it, I guess. And at last I just have to return the count, right? And it will, this recursive function will do the work. So in the recursion, we just need to write for just one small test case, and if that small test case is running, if you've handled the all the base cases like this, when you are decreasing the n, then what is happening? So it will, then you have this leap of faith, you have to leave the code that it will run for larger test cases also, right? So let's just handle this thing of long mod. So it will be long mod. So what it was saying, 10 power 9 plus 7. So 1, 1, 2, 3, 4, 5, 6, 7, 8. 8 zeros and then 1, 7. It will be 10 power 9 plus 7. And at last, I will just say return count. So let's now compile and run this program. So there are several errors. So let's say, okay, so it is not cat, it is cat at, right? So there was this line only which was showing throwing the error. So okay, so let's compile and run again. Okay, so there are still some discrepancies. Let me see. Okay, so I was checking for the last character, that should be less than equals to 6. So why I'm writing n minus 2 here? It should be n minus 1. Great. Okay, so it cannot find the symbol. I have written something at 80. Okay, this is capital here. So I'm making some silly mistakes after completing the whole code. Okay, so what is saying that possible lossy conversion. So why I have declared long, declare it as int, and I think it will work fine. So if more error comes, I will pause the video and then resume it again. So let's see. Great, we do not have any such more errors. So let's compile it for our first test case, that was 1, 2, and 3. Okay, so compile and run, and if it runs for this test case, we will be sure that it will run for our larger test case also. So it's time for now to hit the submit button. But before hitting the submit button, since this is a recursive solution, right? This is a recursive solution and the time complexity was given 10 power 4. And what are we doing? That we are always opening two branches, right? And we are going from n to like till 1, right? So it will be 2 power n, right? There are n, height of the tree is n, and at each level there are two branches opening, so it will be 2 power n. So if you do 2 power 10 power 4, it would definitely get beyond 10 power 8 and it will give TLE. So if you're not able to understand this 10 power 8 logic, I always mention in my video that I have made a video on this time complexity video. Time complexity, you must watch that video, it might be flashing up here now, right? Okay, so 10 power 4, the worst case you can use is n square, right? Because it will be tight bound as 10 power 8 and you can go below as n log n and root n and everything which is less than n square, but the worst will be n square. If you go above n square, then you will surely get TLE, and that's what happening in our case, that we are coding the recursion solution. But since we code each and every approach here, so let us see. So that's great. We were just looking for this. We were like hoping the TLE would come. Okay, so TLES came. So what's the thing to optimize recursion? Recursion is optimized in two way. That is DP, and DP is done using either memorization or either tabulation. So we'll discuss all the two approaches because we need to understand the question and the coding in depth, right? So for the memorization, what we do, I have already made video on memorization and tabulation also. I will not explain you what is it. You must go and watch that. And let's see. So memorization is nothing but when you are, I'll just explain it once. So when you are making some recursive calls, let's say you have call for f of 6 and f of 4, and then going till f of 0, you are calculating f of 6. So let's say this was f of 7, and again you call for f of 6 here again, let's say, suppose. So instead of going till f of 6 to till f of 1 to then return the f of 6 value, you just use this f of 6 here, store it in a dp array, and then just use it here. Memorization is nothing but when you do a recursive branch, when you form a recursive branch, store that value and instead use it to if the same value again comes. So what we will do, we will make a dp here. So we will make dp, and the n value is given as 10 power 4, right? So we will make dp is equals to new int 10 power 4, and we will do just plus 1 in case it doesn't go out of bound for any case. Okay, so in dp is new int 10 power 4 plus 1, right? What else we need to optimize? So first we need to fill our dp with -1. Why -1? Because you can fill with any number. That number should not be the answer in any recursive call branch. That's the main point. That's it. So I have filled with -1. As you can see, -1 will be never be an answer for any possibility. The minimum answer for any possibility is 1. So the character is 1. So we did that, and now for the every recursive call we need to store that answer, right? So instead of returning count, I will store it in dp of n is equals to count, and I need to return also that in all the bunch of test cases, I will see that if at all, if at all whenever it encounter that dp of n is not equals to -1, that means that dp of value has been updated. So we have reached our answer, and you just return the dp of n. That is it. These were the three lines we need to add in this code. And let's see, compile and run, and then we will submit the code. Okay, so it should not be dn, it should be dp of n. So great, your output expected output matches. And now if I submit the code, the recursive complexity has been now converted into an iterative one. And now as you can see, all the test cases will pass. So great. So it is now have been converted into time complexity O of n, because while making a branch, we are just visiting just once, right? And we are storing that answer. And whenever the branch comes to find that thing again, we just use that answer. So we have converted the time complexity of 2 power n into an iterative one, that is O of n. And space complexity, since we're using DP array, so that will also be O of n. So that's it for today's video. Okay, so one last thing, that this was the method of memorization. So I have also coded the approach for tabulation. I will just paste it here, because you need to know that why and all the memorization and tabulation, why those approaches differ. So memorization was nothing but whenever you are making a recursive call, you need to store that answer there then and there, and use it whenever that again recursive call come again in our recursion. Tabulation is that we will not do the recursion in the starting. Even we start with the iterative approach. And tabulation is, imagine just a table here with have four like something like that. So tabulation is nothing but we'll start from the lower value, and then we will go to higher value, right? So I will just show you the code of tabulation also. Okay, so that's the code of tabulation. I don't want to make this video much longer, that's why I have written this code, and I just pasted it here. So let me explain you that what's happening. The same logic is there, but what's happening, I just tell you, I'll give you a quick code walkthrough. So we have made a log mod of 10 power 8 9%. That's very obvious. And one thing that we check, that if the starting character is 0, then you have to return 0, right? We made a dp array, and I store dp of 0 and dp of 1 equals to 1. Why? Because dp of 1 is just saying that if the number of characters is 1, then the answer is 1, right? And I'll take it. So I'll just give you a walkthrough here. So what I'm seeing now, that the thing for the trailing zeros also, we need to return 0, right? So this is nothing but just checking that if there are trailing 0 or there are consecutive zeros between our test cases, right? So that is it. And this next for loop is for this thing that if the new character comes, then we have to count the possibility of taking it as pair and then not taking it as pair, right? So okay, so let me give you a quick dry run of a small test case. Okay, so this is the pre-processing thing that is happening. I'll just explain you for the small test case that str1 and 2, the index is 0 and 1, and the dp I made for n, that is 2, that is n plus 1, that is 2 plus 1, that is 3, right? And it will look like this, the 0 1 2. And so dp of 0 is nothing but about there is an empty string, then I'm returning 1, and dp of 1 is actually saying that my current string is 1, right? And dp of 2 is saying but my nothing but my current string is 1 and 2. So what it is saying, so what's happening here is when I'm this pointer for I equals to 2, I'm starting my processing, right? For so when I'm I equals to 2, I'm saying that this is my string and I'm at this character, I need to process this character. So what I'm saying is that if it is, if it is what greater than 0, so I equals to 2 and this the indexes are 0 and 1, so that's why I'm writing that if str of I is greater than 0, similarly we did in the recursive case, right? So what I'm doing, that I'm taking the answer from the previous thing, as you remember, from the n minus 1. So what I'm saying, that dp of I is nothing but the answer from all the remaining numbers in the left hand side, right? So that's what I have written here. So this was the thing for not taking as pair, for not taking as pair. Now we have to take it as pair also, right? So same thing, I need to check it, that this was the thing of I minus 1. So I need to check that I minus 1 should be less than equals to 6, and I minus 2 either be equals to 1 or either be equals to 2, right? That was the case we were checking in the recursive also. So that's what I have written in the code also, and I will just say that dp of I is nothing but dp of I plus dp of, it was n minus 2, right? So here it will be I minus 2. That is it, guys. So I'll just show you again that I minus 1 is greater than 0, then dp of I is equals to I minus 1, as I showed this in the pseudocode. Similarly, in the I minus 1, the last character should be less than equals to 6, and I minus 2 and I minus 2 can be equals to either 1 or either 2, right? And I've taken the answer from n minus 2 characters. So I hope this thing is very clear to you. This is the tabulation approach, and at last we have just returned the dp of n, right? So okay. So if I just show you, it will be like dp of I minus 1, that is 1. It will be updated as 1 here, and then it will say that the dp of what 2 is nothing but dp of I, that was updated as 1, this one, plus dp of I minus 2, that is also 1, this thing, dp of 0, and it finally returns as 2, and you can see that the 2 is answer here. So that's it for today's video. I hope you like my content, the way of my teaching with all the pseudocode and the approaches. So if you have still not yet subscribed my channel, please subscribe it, because it actually takes a lot of energy and dedication to make the video for you guys. So subscribe it, and we can learn, grow, and move together in this our coding journey. So last thing, that's my DSA repository. You can start and fork to get it with the source code, and that's my Instagram channel, the public account I made just for you guys. You can connect me here 24 into 7 for any doubts and guidance, as well as on LinkedIn. And thank you. YouTube family is growing with an exponential rate, and we will. This was our day 98. In the 2 days, we will be hitting day 100. So if you are with me with day one, we will be surely making our journey worthwhile. So that's it. Let's meet tomorrow in day 99. Till then, keep studying, keep growing, and take care.